Yeah, it's recording. So every week we'll be meeting on Sundays from 6 to 8 p.m. The course will be of 9 weeks. The meeting link that you have joined with today, that is the same meeting link. We will use it for every session. Okay, so you can note it down. I have also shared it in this slide. The lectures will be recorded and all the course related discussions, announcements, everything will be made available in the Google Classroom platform. And also I'll be taking note of the attendance. So it is going to be shared with the ISIS people, and um, also irregular class participations and etc. That will be also noted, so that I can uh, ask them to issue certificates for you guys at the end. Okay, so try to be regular if you're enjoying this course. That's it. I don't know. Since for this time I have invited you guys to join the meeting in this MS Team platform, but I think you may not be able to use the chat option. So whatever queries you have to unmute yourself and speak. And during the session, if you have nothing to say, I would request you to mute yourself, keep yourself muted, so that unnecessary disturbance doesn't happen during the meeting and we learn things smoothly. All right. So just with this, like the first slide that I'm going to go through for the first session is what is bioprinting or 3D bioprinting? What is it? So this field that has come up in last 10 years, you can say, is actually a type of 3D printing that people have been working on way long before than that. So it's a type of an additive manufacturing process. What is additive manufacturing, you ask? So additive manufacturing means when you are manufacturing a product by adding materials. So you can add material in a layer by layer fashion, all right? Or you can add like every piece is made by adding material. That is called additive manufacturing. There's another section of manufacturing that is called subtractive manufacturing, where you start with a lot of material and you scrape out the excess in order to get the final product. Like sculpting, you have seen sculpting where they take a block of marble and then they chip off the excess in order to create a statue. That is subtractive manufacturing. In our like traditional way of manufacturing that is used in industry is additive manufacturing. All right. And people from the area of mechanical engineering, material science, they have been routinely using this process to manufacture various kind of products. All right, so this 3D bioprinting field is just a subset of that technology, where we are concerned with using biological materials in order to create product like artificial tissue. So this is the definition that I found that defines the area of 3D bioprinting. Definition says it is the use of computer-aided transfer processes for patterning and assembling living and non-living materials with a prescribed 2D or 3D organization in order to produce bioengineered structures serving in regenerative medicine, pharmacokinetics, and basic cell biology studies. All right. So basically, it's trying to say that we are assembling living and non-living materials, all right, using computer aided processes. Like we are involving softwares, we are involving automation processes in order to assemble these living and non-living materials in either a 2D structure, like only limited to XY plane, or a 3D structure, where we also add a third dimension to the structure. And so that the final product mimics or resembles a bioengineered structures. Now, these bioengineered structures, they are useful in various studies in the field of regenerative medicine, where the people are concerned in replacing or restoring or repairing any damaged tissue. Okay, in the field of regenerative medicine, pharmacokinetics, where people study the like drug diffusion, drug discovery, then drug selection and all. So mainly related to drug screening. So you can use these bioengineered products to test the efficacy of various drugs. And also for cell biology studies, basic cell biology studies, you want to know the biology of stem cells in 3D, right? So for that, you can create a 3D organization, 3D structure using bioprinting, and then see how the stem cells are behaving in that. So, so these are the application areas where 3D bioprinting are used. So basically, you are going to use 3D bioprinting to create volumetrically sophisticated structures. So if you just want to create a thin layer of, say, tissue, you don't need bioprinting for that. You can use a cast and molding technique. But if you're trying to create something sophisticated, like 2D, but you want to pattern specific cell types at a specific location, all right, and you want to do it faster and at precision, then you will need a sophisticated technique like 3D bioprinting, all right. And what is the material or the ink? Like for 3D printing, you need a ink. Similarly, for bioprinting, you need a ink. So what it is called? So it is called bio ink. What is bio ink? Bio ink is usually a mixture of cells and other bioactive components like growth factors, um, like drugs, right? Whatever proteins, cytokines, chemokines. So any biologically active component that may be susceptible to heat, degradation, right? Derived from biological source, like even the media, and we add some serums, right? So those are all bioactive components you add with cells. And cells can be of either primary cells, cell lines, iPSCs, stem cells, organoids, spheroids. So like any cellular origin stuff, right? And you mix it with a biomaterial so that it becomes printable. We will come across this term printable later. Or you can also use the bio ink without the biomaterial, just as is, all right. So we make a special recipe in order to make an ink, and that ink should be printable at the end. Okay, we will understand how to make a printable bio ink later on. And in bioprinting also there are different modes, and each mode of bioprinting has its own guidelines to make a printable bio ink. Okay, we will come across that later. Then you use 3D bioprinting to manufacture regenerative implants and in vitro models. So regenerative implants, as I told you, is used in the field of regenerative medicine, where surgeons and biologists, they are trying to create artificial tissues, like say skin tissue for repairing wound, right? For treating chronic wounds, or replacement bone is broken, a large piece of bone is broken, and you want a bone substitute. So where the purpose is to repair, restore, and improve the function of normal tissue. So those kind of implants we can make using 3D bioprinting. And also in vitro tissue models you can create. So it is useful in the area of drug discovery, drug screening, where people spend billions of dollars, right, in order to find the drug that is most suitable for treating a particular condition. So often animals that are generally used in preclinical trials, they are used to screen out thousands of drug candidates. What happens when those drugs goes to clinical trials, like actually goes into human body, most of these drugs fails. So now the trend that they are thinking is to involve intermediary step between preclinical trials and clinical trials, okay, in order to make sure the thousands of drug candidates that for developing those drug candidates, the companies spend billions, so that like at least more, at least from 1,000, say let's say 500 of those get passed in clinical trials. In order to make sure higher rate of success in clinical trials, people are now thinking to involve this intermediate steps. This tissue engineered in vitro models, they contain human cells, and also biomaterials of human origin or biomaterials which are biocompatible with human. So this concussion, which is already biocompatible with human system and very much mimics the human system, if we use those system rather than like use those system to drug screens and get some results out of it along with preclinical trials like we do in here pigs and rats and mice and rabbits, so that it will give much more supporting data to ensure that this drug will pass clinical trials. So we are trying to increase our success rate, make more profits, basically, right? And also, there are many countries, including India, which are passing various laws to ban the usage of animals, all right, for drug screening and cosmetic testing. So when this kind of laws are like coming into effect, so even we cannot rely much on preclinical trials, right? So that is why that is why we need to create more and more tissue engineered models, in vitro tissue engineered models, which mimics the structure and function of our native tissue, right? So overall, you understood that this technique, 3D bioprinting, is very important tool in the field of tissue engineering and regenerative medicine. All right. Any questions so far? All right. Moving on. So there are various modes of 3D bioprinting. In this course, we will discuss 4 of them in different sessions, but briefly, let me tell you what they are. The first mode, the most common one and most cost effective one, is the extrusion based 3D printing or 3D bioprinting, where what happens, the bioink is loaded into a syringe and in presence of some external pressure, it gets extruded out of a smaller diameter needle or nozzle. So when it gets extruded, it forms a filament. All right. So, and using this filament, we can create various 2D and 3D patterns. That is called extrusion based 3D printing or 3D bioprinting. This is one mode which is very commonly used. Next is called inject droplet based 3D printing. Fun fact, the first 3D bioprinter that was made is actually a modified version of a commercial inkjet printer, like that is used to print papers, right? To get paper printouts. So using that inkjet printer, people modified it in order to print cells. So that was the first um, demonstration of 3D bioprinting. So they basically, so here what happens, here a bioink is loaded into a syringe again and using either thermal or piezoelectric actuators. So they basically give a stimulus on when the bioink droplet will be dispensed. So that stimulus is basically automated. And as the printhead moves over the substrate, small tiny droplets of bioink gets deposited on the surface. And using droplets, here the key unit of the printer is a droplet. Using droplets, we create a 3D structure. This is inkjet, a droplet based 3D printing. Then there is another technique called laser beam induced 3D printing. So here we use laser, all right, very high powerful laser, and this laser gets uh, concentrated over a slab. Now, it doesn't directly hit the bioink, but there is a layer of protection, okay, over the bioink. So this layer of protection absorbs the excess energy of the laser pulse, and wherever the laser falls, the bioink gets separated out from the slab. Okay, so there is a layer of protection, absorbing layer. Okay, there is an absorbing layer, and just below it there is the bio ink. And wherever the laser pulse hits the absorbing layer, from that point, a droplet of bio ink gets deposited on the substrate. Okay, so here also we are, the unit of printing is here a droplet, and this technique is using laser to precisely place the bio ink on the substrate. All right, because a laser is very precise, more precise actually. So you can create very sophisticated structures of very low resolution, sorry, of very high resolution, using this technique. This is laser beam induced 3D printing or 3D bioprinting. This is the fourth technique. This is called stereolithography. So this stereolithography printing, you can classify it under a broader field that is called VAT based 3D bioprinting. Why I'm calling VAT based? Because here we use a bath of photo cross-linkable resin. There is a bath. It is completely filled with photo cross-linkable resin, and from the top there is a laser source that gets projected over our 3D model. Okay, and the digital image of that 3D model, it gets projected over the bath of photo cross-linkable resin. So, and this is the platform. This platform is completely immersed, okay, within the bath. So as and when first layer gets projected, the light gets projected, whatever path material was there, it gets cross-linked. All right, and then it moves slightly down. Okay, for the next layer to be cross-linked. When the platform moves slightly down, the ink of the bath, it covers the preceding layer. Then again, digital pattern gets projected on the second layer. Okay, it gets cross-linked, and then the platform moves down. In this way, layer by layer, the ink of very thin layer gets cross-linked. It is a very slow process. Like this platform, it moves very slowly. You cannot actually notice that movement that fast. All right, there are other geometries as well where the platform is like on the top, and and the bath is in the below, and this platform is going down and then up, going down and up. Here also this platform is moving up and down, so that the bath of the ink, it covers the layer, light projects onto it, it gets cross-linked and moves down. Then again a layer of ink comes, it gets light projects, it cross-links and then come down. In this way, layer by layer, a 3D structure gets formed. So here we are using light, all right, maybe in the visible region, and the resolution because of it that you will get is very nice. Okay. So any queries so far? So these are the four types of 3D bioprinting that are most widely used right now in the literature, and people are using these techniques for making tissues or structures of various types. Any queries?
Ma'am, in the second and third type, in which, ma'am, can you change the slide to the
Yes, yes,
previous one?
yes, yes.
Ma'am, the thermal and the laser, how they are different?
So here, the ink is actually present inside the inkjet bioprinting. Here, the ink is actually present inside a syringe. All right, and this syringe is connected to a robotic arm. That robotic arm is moving over the substrate, and as it is moving, it is dispensing droplets. Here, what is happening? Here, there is a laser. There's a laser source, and it is giving pulsated laser at some specific points over a substrate. So the substrate having the bioink is stationary, all right, and it is placed directly over the receiving platform, and the laser is basically giving a point. The laser is inducing where uh, like giving a pulse, like tiny pulse at different locations over the bioink platform. Okay, and as the induced pulse is received, one droplet of bioink is coming off on the substrate. So here the moving head, there is no moving head, right? There is no syringe, there is no print head. So there is a stationary platform, receiving platform. Then there is a stationary container reservoir of bioink, which is protected by an absorbing layer. What is moving here is the light. The light, wherever the laser shows is pointed on the substrate, from there, a droplet of bioink is getting dispersed and um, coming off on the platform. So here the unit of bioprinting is droplet, that is same. But if you think about the resolution, which will like higher resolution, which technique will give a higher resolution, is basically the laser based one, laser beam induced 3D printing. So that will give a higher resolution, all right, because laser will fall, or laser will induce the dropping of this or the formation of the droplet in a much more precise manner in comparison to droplet based one, because here we are relying on a moving head. All right, it is possible that while moving, the droplets, subsequent droplets which are closely spaced, they can get mixed with each other, or instead of a tiny droplet of sphere type of a geometry, it is possible that you will get some kind of a like irregular droplet. So this kind of errors are possible in inkjet droplet based 3D printing. Okay, does this
Understood.
clear your doubt? Yeah, okay. So moving on. So if you are suppose in going to explore this field of 3D bioprinter and you join a lab, they don't have a machine with them, and you join as a PhD student, you are asked which type of bioprinter should we use, okay, for the research. So you should know there are a couple of options available right now. So first option that most people would like to go with, and especially it is a very good option for those who are very new to this field and want to learn, is by choosing a commercially available 3D bioprinters. So it's a good news that now after 10 years of research in this field, there are many companies, mostly they are all abroad. Companies like Cellink is a US based company, Organovo. So these are Canadian, Finnish, Sweden. So these foreign companies, they have started making these bioprinters. Like these are the images of the bioprinter that are currently available. This organable one looks very mechanical, whereas selling printer, LV. So these are very what do you say, fancy looking types. And personally, I have worked with Cellink bioprinter. We have a Cellink one. I've also worked with LV. So these are the two companies that are mostly used in India. In Indian labs, I have seen it. But the problem with these bioprinters is that they are very expensive. Okay. So the selling one that we have is that cost around 40 lakhs. So a new lab who wants to work in this area and is short on funds, they will find it very difficult to get a commercial bioprinters. Otherwise, they have all the necessary built-in features that you need to start your bioprinting process. Okay, but only drawback is that they are very expensive. Okay, and also they are not very customizable, means whatever features the company provides, you have to stick with it. So you're limited by the company and the features. You cannot be very creative in your approach. All right. So what other options is available? I think someone was in the No. All right. Yeah. So what other options are available? You can make your own 3D bioprinter. Okay. So this paper was published in 2022 by is a Adam Feinberg group. So Adam Feinberg is a very reputed professor in this field of 3D bioprinting. He's a professor at Carnegie Mellon University, Department of Mechanical Engineering. So their lab actually developed their own 3D bioprinter by reusing a normal 3D printer. So they modified the components of a normal 3D printer that is available and that is very cheap and converted into a 3D bioprinter. In fact, I have seen that they do workshops as well, where they invite people all around the world so that they will learn how to make their own 3D bioprinter. Okay, and then you can take that machine home with you. Okay, so that's a cool thing that they are doing. So if you are ready to learn the entire process of making the machine and all, and make it customizable, so whatever type of 3D printing you want to do, uh, you want it like completely customized, completely dismantleable, right? So that is a very good option, and it is going to be cheaper than buying a commercial one. But don't fool yourself, like it will be very cheap. It will be expensive, okay? It will be expensive as it is going to be used for research, but it will be not as expensive as purchasing a commercial one. Only drawback is that you will have to spend the initial time on learning the technology, on learning the software, hardware components, like what each hardware component do and all. So that will like take up significant time, maybe a year or two, okay, to learn this process. I think someone is in the waiting. Yeah. But it's a very good option for the new labs who are keen in learning this or get into this field of 3D bioprinting. Now there is another type of 3D bioprinters that is coming up, is in situ 3D bioprinters. So these bioprinting, as the term suggests, in situ. Here what we do, we uh, take information of the site where the implant is going to be uh, made, say 3D bioprinting implant you're making, and you take the information of the site or the geometry of that wound by doing an MRI or CT scan. You take this information and construct a CAD model accordingly. Then you give that information to a robotic arm, robotic system that will directly print the bio ink on the wound site of the patient. So traditional or conventional way is to first bioprint and then culture it in cell culture conditions and then implant. Here, the bioprinting happens directly on the patient. That is a very new field, and many countries like United States and China, they are already ahead from us and they are working on this kind of setup, which can basically help the hospital staff like nurses and all to take care of wound care or in surgery. So like these systems are also new systems that we can think of working in the future. All right. So now that you have selected what type of bioprinters you want to use for your research, then you have to understand what are the steps involved in this process. So first step is to generate a 3D model, 3D digital model, because it is an additive manufacturing process. You have to, and there's a system involved which can read um, the 3D structure that you want to make. So you have to first start with the 3D structure, what you want to make. Okay, so that is the first step of 3D bioprinting. Whether you take that information from medical images like MRI or CT scan, or you think of it on your own, like you start with a sketch and then you design it. So either way, you have to start making a CAD model. Once that is done, you will have to calibrate your 3D bioprinter machine before starting the printing. Calibration means the machine will measure X, Y, and Z axes so that it will know the dimensions. So if you have planned to make a 15 mm by 15 mm type of a model, then the printer will be directed to make only 15 mm, not more than that. Okay, so dimensions, to get the accuracy in dimension, the bioprinter has to be calibrated. Then bioprinting parameter selection and optimization. This is a very important step in the bioprinting process. You have to select what type of ink you want to use, the nozzle diameter, length, geometry, then the printing speed. If you are using extrusion based printing, then you have to select pressures. If you're using light based printing, then you have to select the laser power, right? Then, if you are using inkjet based printing, then you have to select the frequency of the droplet, how fast the droplets will deposit. If you are using stereolithography based printing, then you have to select the, again, the light intensity comes up, and then the speed at which the platforms moves up and down. So these are all key parameters that is involved in different bioprinting process, and you have to optimize it. Okay, so each ink, what is, so you develop your ink, then for that ink you have to optimize those parameters, and these parameters are specific to that ink. It cannot be translated to another ink. Okay, so this is a very time consuming, but it's a very fruitful process to ensure that you get reproducibility in your process. And then when you have done this third step, you go and start your bioprinting job. Okay, you actually bioprint. That is the fourth step. And after bioprinting, you do some post bioprinting processing. Like, most of the bio inks, they are not structurally stable. All right, they will have a tendency to sag after the printing. So to ensure the stability of the structure, we do some post cross linking steps. All right, and then after that, we also do tissue culture. Means we culture the cells inside the 3D structure. We give some nutrients and oxygen, and culture it for a few days before it is ready for its application. So these are some post bioprinting processing that is totally dependent on what tissue you are making and what is the end application of that tissue. Okay, so these are the five steps important to successfully bioprint a tissue engineered product. Okay, so in this today's class, although I know we have spent quite time in the introduction, but we will soon begin with understanding the first step, that is how to digitally design a 3D model. Okay, so what kind of softwares you need to learn? So the hardware part is you have to learn the machine. So if you are commercially purchasing or making it yourself, you have to learn how to operate that machine. Once you have done that, you also have to know some softwares in order to help you. First is CAD, computer aided design, to generate the 3D model of interest. So that is what the first session, like the first thing that we're going to learn. Next is CAM, computer aided manufacturing. So this step actually helps in translating that CAD model into series of um, instructions for the printer to understand, and the printer reads those instructions, and it understands where to move. So it helps generating a pathway, bioprinting pathway. I will also show you how that instruction looks like. Okay, and then this is the third step that most people are like started doing. So first and second step is the primary stuff, like you have to learn it. If you want to do 3D bioprinting, you have to learn first and second step. The third step is optional, and I think that is much more advanced and required for those people who are interested in understanding how their bioink works. So this step involves using simulation tools to understand the flow of your bioink, flow behavior of your bioink, like before, after, and during the process, so that you can understand the failures, why this failure is happening. To get more insight and rectify those failures, you can use these simulation tools to understand the flow of your bioink. So this is like the third step, but it is optional. It is not the primary thing, and if you, even if you don't know how to use the simulation tool, you can still do 3D bioprinting. Okay, so let's talk about some softwares and what is CAD designing basically? The software that are available right now is SolidWorks, CATIA, Tinkercad, Fusion 360. So these softwares are commonly used. Tinkercad is free. Fusion 360 is like free for college students. SolidWorks and CATIA I have not used, but these are mainly the softwares used by mechanical engineers to design parts and all. So you can all, if you are already familiar with these two softwares, you can go ahead and use it for the bioprinting process as well. So it just has to it help you make a CAD design. That's it. Okay, it doesn't matter which area is using what. But I feel since I didn't knew SolidWorks and CATIA initially, and as a biologist, I felt that the interface of Fusion 360 is much more user friendly. That's why I decided to learn and go with this. And it has, other than CAD designing, you can do a lot more. You can do simulations here as well. You can do bio rendering, like rendering and create 3D art and all. So that's why I felt like this is a much better software. Okay. And it gives you free access if you have a college ID and all. Okay. So once you have made the CAD model, you have to export that CAD model into STL format. Please remember it, STL format for any 3D printing objective. Even if you are using a normal 3D printer that is available like Prusa printer and all, you have to supply the CAD model in .stl format. There are various other formats as well, so don't get confused. Okay, so this STL stands for Standard Tessellation Language. I'll show you. When you convert it into an STL format, your structure basically, or the surface of the structure, it shows up as a series of triangles. Okay, and these triangles makes up the surface. Okay, so that's why, and that is what the printer understands. The software of the printer understands. Okay, and you can use to you can use this softwares to design lattice based scaffolds for tissue engineering, where the required type of structure needs some pores and series of cross hatches and all. I'll show you what is lattice based scaffolds means in tissue engineering. Or you can directly use patient data like MRI scans and CT scans and generate STL files out of it. So there are again softwares available to do that, like Materialize, Mimics, Vitria, etc. So these are commercial softwares, and since usually engineers don't have access to medical scans and all images, it is usually very restricted to doctors. So that's why I haven't learned it yet. But in future, I would like to understand because I feel this is a very cool thing and very much relevant in translation perspective. Okay, but we are going to stick with the basics. As I told you, this course is all about basics and make you at least get started. If suppose you get the opportunity of 3D bioprinting, you can at least start and you won't hesitate to explore this field. Okay, then what CAM? All right, so as I told you, this step basically uh, gives instructions to the printer where to move and where to deposit the bioink. So here in this step, we define the printing parameters like the nozzle type, the filament width. So these are the parameters. Some then speed we define. Okay. Then if there is a need of support structures, like yes, you have made a structure that has a tendency to collapse. Okay, like a tree with branches coming out of it, and you want to make sure those branches stay at it as it is. So we can add some support structures. And if you are using multiple material where each print head is having one material and you want to uh, command that all these material will get deposited at different step, so that also you can incorporate those instructions, you can incorporate. And what you get out of it, what is that instruction file is called? It is called a G code. Okay, and also the 3D model that you have given, the STL file you have given, this in this step that file gets cut into digital patterns, like series of digital patterns that are 2D. Okay, and in this way the printer understands that each layer I have to deposit, this is one layer, and then the printer will move up, then another layer. So that the G code helps the printer understand what is the model. It cannot read STL file directly, but it will read the G code. Okay, and G code will have all the instructions about your ink, about your selection of material, about your like nozzle type, etc. and all. Okay, so here in this figure, this is the G code. This is the example of a G code. It is nothing. It is a very simple language to understand. All right. It's basically gives instructions in X, Y, Z directions. All right. And there are some commands like E that helps the printer to understand when to extrude. X, Y is basically the coordinate. Like the printer will have to move X in X direction 5.663, and then in Y direction 13.673. In this way, the printer understands the coordinate. So the second step that I talked about, calibration of the 3D printer, is very important, because during calibration, the printer measures the axes and immediately comes to the origin, because from the origin where x y z are all zero, from there the G code will start executing, because it has the coordinates. All right, and it will also tell the printer when to just move, when to move and extrude, or deposit a droplet. So these all instructions are given in this G code. We will not learn how to write a G code, okay, in this course, because there are readily available softwares, free softwares available, like Cura, Slicer, where you will just upload your digital file and they will give you the G code, okay, according to the file. Then you can modify it if you want, but you don't have to worry about writing the G code on your own. And there are also this feature available in commercial printers. So in commercial printers, they have the built-in softwares, okay, which will in the machine generate the G code for you. You just have to upload the STL file, and the G code will be generated in the machine itself. If you want to troubleshoot it, like suppose the G code that the machine created is not making the pattern as you need, then you can rectify some steps. That's it. Okay. And the G code is very easy to understand. And there are 20 minutes, 10 minutes tutorial available online as well, that will give you the entire thing that you need to know about G code. So it's a very simple language to follow. Okay. So, but I will not discuss about G code writing or anything like that. Okay, in this course. So ultimately, what we are doing for 3D printing, first step is we're making a digital model, and then we export it into an STL file. So as I told you, this type of triangles get formed. If you see, these are triangles. The series of triangles, they form the surface. That is the STL file. And then you supply it to a software like Slicer or Cura. This step is called slicing. Okay, CAM that I told, computer aided manufacturing, it is also called slicing step. So in this step, you use a software like Slicer or Cura to generate the G code. Okay, and it is the G code that ultimately guides the printer head to move, robotic arm of the printer to move in X, Y, Z direction, and ultimately deposit your material at definite positions. Okay. And lastly, if you are interested, you can always learn some computational fluid dynamic softwares, CFD softwares, and simulation tool to understand how the input parameters like the pressure, nozzle, print speed, flow rate, whatever input parameters that you have given is affecting your outcome. Like the structure fidelity means whatever CAD model that you have supplied, if suppose after printing you're not getting the same shape, okay, so why the failure happened. Okay, we want ultimately the design structure and your CAD model, it should look exactly same, it should look alike. That is what we want ultimately. Okay, so if there is some failure in that, why is it happening? So you can simulate those conditions in the software and play out thousands of scenario in a short period of time, rather than doing experiments thousands of times. So this software, using software and these simulation tools, like takes less times and makes you familiar with the errors more fast, in a more fast manner, but setting up experiments, okay, even doing 3 4 times of that experiment takes more time. That's why people are choosing to use this kind of softwares. So what kind of software that are available for doing it? There is Comsol, Ansys, OpenForm, etc. These are all commercially available softwares, and there are very good tutorials available online that can help you learn these softwares and apply it in the area of 3D bioprinting. Okay, so that's it for the introduction. Now we will start with the demonstration. So before I begin, if you have any queries regarding any point that I discussed so far, let me know. Did you find it interesting so far? Did I speak too fast and you couldn't catch something? Let me know. I can go back, because after this, like after I start Fusion 360, it will be a bit difficult for me to go back because I'll be showing the software and all. So that's why I'm asking if you have any queries.
Ma'am, it's fine, ma'am. You can carry on, ma'am.
Okay, all right. Thanks for the feedback. So if you have not installed the software, let me show you how you can do it. You have to go to autodesk.com. Okay, and you have to click on products, and there is Fusion. Earlier it was called Fusion 360, but now they have changed the name, but it's the same. The logo is the same, Fusion. You can download the free trial, that is for 30 days, and then you will be asked to pay for it. But if you're a student, and so it is around, since I'm in United States, so it is showing in dollars, but you can see the INR cost as well in your home. Okay, so it changes, or you, if you have a student ID card with you, you can always choose that to get a free 1 year trial. So every year they will ask you to renew it. Okay, they will ask whether you're still a student or not. Okay, so they will, so you get a free trial for a year. The next year also they will ask the same to get your, they will ask for your ID card and all. So these are the three plans. The free version, as I told you, this is for hobbyist. So this is like limited free version. I have not used this version because like I didn't need to, but you can also try out. This is also free, but it will restrict various options. All right, you cannot use the software completely. But if you're a student, you can unlock the educational access. This is the software. Okay, selected Fusion. And so if you're a student, you will get 1 year subscription for free. If you're an educator, say a professor, you can select this as well. Or if you're an IT person and all. So if you're a student, select that. You have to continue. Then they will ask you to give your details, all right, your email address and all. And then your educational institute, which institute you are studying in. So since I have already done it, but let me show you. So I'll use my IIT Kanpur email ID to access it. You can use your institutional email ID too. So it is not like I'm in IIT Kanpur, so that's why I'm getting. It is the same for all, It is like you just have your college email address. Yeah. So you have to give your name like this. You have to give it a role. So I'm a student there. Give your email, birth, date of birth, and all. right? And then you have to give your school information. So like I'm going to give my IT Kanpur information. Similarly, you can do it for your college as well. So see, once I wrote IIT Kanpur, so it is showing that they already know. Okay. And then you have to select the institution type. It's a university. So it's very straightforward. So once I wrote IIT, it gave us options. Now, suppose if you are from a different institutes, let's say Delhi University, that will also come up. So you don't have to worry about that. So you just have to write your own college name. And then your website link and all, when do you graduate? So all this thing you have to mention and then you have to continue, right? Um, iitk.ac.in, your my graduation is 2025. Okay, information is accurate, you have to continue. And then you have to, since I have already done this, I have already installed the software in my computer. That is why it is not showing this educational verification step for me. But in this step, you will have to upload your student ID card. Okay, there is separate page that will come up. And once that is verified, then you can submit and get this subscription. That's it. So after you complete it, you will get the link to download it. So mine says that it will expire next year, 2025. So I don't have to do it now. I'll directly, now if you have understood how to install it, I will now directly go to the software. So once you have installed your software, it will take some time. It's a large software, like around 2 GB almost, and it will take up some memory of your computer. So I recommend you to use at least 8 GB RAM computer and with memory, so that you can use this software without lag. Okay, having a good laptop is essential, you know. So once once you have this software installed, it will open up a page like this. Also, you will have to create an Autodesk email ID and password. Like you have to create an Autodesk login as well, because it will create an online cloud storage for you here. So this is my profile where like I can see all the stuff that I have done, like my personal information and all. Those are all available here. So you have to create Autodesk a login information as well. So is it clear till now? Let me know if anything unclear so far. Have you done this step? Did you face any difficulty in doing this installation step so far?
After subscription, what we have to do?
You'll have to select submit. Okay. Then in your email ID, they will give you the link to download. That's it. Okay.
Okay.
So I told you, right? You have to create a login. So that login information will have the thing that you have subscribed for 1 year for free. So once you install the software, you will have to log in, and automatically your 1 year subscription is activated and you will get all the features. All right. Any other queries? Okay. So let's try to understand the software interface first before we begin designing something. So from the top, you will see this data panel, it is called, and you will see all the structures. So it's basically houses your data, whatever CAD models that you have made, and it is all uploaded in the cloud. So this is some of my projects that I have been working on. There is a library as well that will give you some templates to start with, and there are some sample designs as well. Okay, simulations and like tutorials also, they do workshops, tutorials. So Autodesk is a very big community. You can always post some queries in this community and it will help you out. Okay, so here you will get some data. You can also invite people to uh, join your team, and you can work collectively, like 3 4 people can work collectively on a CAD design. That is also a good feature. Then you have to, if you are not having a new design already, so this is a new design, you can always click and another panel like this will show up. This is another design you can make, another project. So I don't need it. Okay, so for CAD modeling you only have to fix on new design. So you can also draw here, like 2D sketches. If any one of you have done engineering drawing in their BTech course, so they know that there is a course called engineering drawing, where you have to draw in 2D the specification of some parts. So you can do that digitally here. You can draw the schematics of the parts and all here. That is not needed for us. Then you can export, this export feature available. 3D print means it will help you convert your object into STL, and you can also capture the image of the 3D model directly from here in order to share with anyone else. Okay, then this is a save feature. That's it. So for 3D modeling, you have to select this option design. Okay, if you select another object like option, then it will not help you, or it will not give you the feature to design. So like there's a render feature, right? That is not for 3D designing. Then you can also use this for simulating different conditions here. So that is completely different. So that is why I request you to get the free version using your college IDs, because through that you will get all these features. And in suppose in future you want to use this software for other than CAD modeling, you can use it. Okay. Now we will stick. So there are some tabs here like solid, surface, mesh. If you click each of these will have a different feature. Okay. You don't need all of them right now. As in when you will do more advanced modeling, you will get to know it. So let's start. So for basic stuff, used to begin with, you have to select the solid one. Then this is the browser. So this browser shows you the bodies, the origin. So this is your origin, right? This one. This is your x-axis, y-axis, and z-axis. This is the origin. You can start from the origin here, and there are planes here. So that will show here. Okay. Someone is trying to. Yeah. And so then you can use this cube on your right hand side in order to navigate around the plane. Like you can use your, so you can use this cube to move around the object. And once you click this home icon, it will come back to this position automatically. Then you can use this feature as well to move the plane, right? So let's try to draw something here. You can click on create, and let's say we draw a box. First, you have to select the plane. I select XY plane and selected dimensions. So you will notice this writing space is coming up. And as you are moving, the dimension is changing. In order to set to a custom dimension, you can click on tab, and it will allow you to write the dimension. It will then lock it. So wherever you move, it will not 100 is set. So this is like locked. And if only way to change it is to again type the dimension. let's say I want 100 mm by 50 mm cube. Okay, and it created a cube for me. Then you can also set the Z height. So now it is telling me how much height you want. So I can type it, let's say 15 mm, or you can just move it like this, 30 mm, 40 mm, 50 mm. So let's say 50 mm. So your body is created. So this is called a body. As you made a body, it will pop up here, and you can hide it, or you can show it like this, and you can center it like this by clicking the home. Now you can use the inspect option in order to measure. Like when I selected this edge, it shows the length is 50 mm, and like this is 100 mm. So this is a very useful feature to remember sometimes, like what dimension did you use and to replicate this structure and all. Okay, now you can modify it much more. Let's say I want to create holes in it. You can select this option, the face at which you want to create a hole, and there you see a hole option comes up, and it will ask you like how much diameter you want, then the degree of hole. So it will basically cut it as you move. I want a hole that goes all the way. So this is, I think I made it 50 mm. So the length I wanted 50 mm. So hole that goes all the way to the center of the cube. So I can do that. You can just click and move like this. And also I find that this option very handy. It helps you visualize where the hole is. So if you move it like this is where your hole looks like. And then here also it is coming like this. It's a very handy feature, this orbit one. And then select. So now you have it. This is the hole. And it is completely empty. When you move around, it is completely empty. Now you can also change the view of your object. So I basically moved it too much. You can always click and come back by clicking the home option. You can always change the display, how you want your design to be displayed. So I have selected originally shaded with hidden edges, because it helps me see the edges that is not visible to me otherwise. So if you use the option shaded, then you don't see the lines, right, of the cube that are behind this face. So that's why I choose to use shaded with hidden edges. Then you can also use a wireframe mode, which is basically a 2D structure. Okay, you can see the structure is having a cylinder that is running through the middle of this cube. Wireframe mode is not very useful, but I find this one shaded with hidden edges very useful for designing. What else you can do? You can always now suppose you're not happy with the dimension, all right, and you want to change the dimension at this stage. What you can do, you can use the move or copy feature. Let's say you select a face here, and this face is selected, and you can move like this face, so it will get extended. So it was originally say 50, and I added 20 mm more, so it's a now a 80 mm thick. Okay, or you can also rotate it to create some other structure like this, but usually let's see, it will not rotate in this direction. You have to select in which direction you want to rotate. You can rotate like this to create some surface like this. Let's say I'm happy with it, and you can also write what degree you want. So I rotated it too much, the 20 degree I wanted, and this way you can create custom shapes. You can also fillet it. So for 3D printing, people like to make the objects bit filleted, means the edges should not be that straight. They want to make it bit curved. So let's say I want to fillet it 0.5, so it become rounded a bit more, maybe 10 mm. You see the edge becomes bit rounded. Okay, this is a fillet option, very nice option I feel. Then you can click on command and select other faces at the same time. In Mac it is called command, and I think in Windows will be called control. So in this way you can click multiple edges like this and fillet it. So it becomes very nice rounded structure. And as I told you, the hidden edges is helpful in order to see which all edges you missed out. So I just moved it like this, and then I selected the edges which are not rounded. So all of my edges is now rounded. It is all rounded by 10 mm, even the bottom one. So you can use this to move around to see if you have missed any edge. So there you go. Then you can also use options like draft. So what this draft does, it will create a slanting. So first you have to choose a pull surface and then the face that you want to draft. And this is type of rotation. Like this you can move around. So it will give you a warning, like now it is inconsistent, don't do it like this, maybe like this. Okay, so whenever the warning comes up, it means you are doing something wrong. Okay, let's say I'm happy with it. This is how the draft I want to look like. It is very useful. Suppose you are creating some kind of molds, you are 3D printing a mold and into which you are going to cast something. So draft feature will help you get out that after 3D printing, when you um, try to take out your molded structure, you draft feature will help you in doing that. Okay. Mm, then you can always start. So this is one way of starting your CAD modeling. Now suppose you know what to design. This is, I just played around with the um, features that are available, but suppose you know what to design, you have a structure in your mind. So I have created some structures in the past that looks like this. So I've tried to create devices that looks like this. All right, and for this you need some planning. You want to know the dimensions and how it will look like. So first thing that I did before designing it or before coming to CAD is drawing it on a pen and paper. Okay, you can use your iPad as well and decide what dimensions you want. Okay, the height, the length, breadth, the structure, whether you want it polygonal, rectangular and all. So first you have to design it on pen and paper. So let's say you have done it and you want to begin. So you can start with this sketch feature. The sketch feature will first ask you which plane to start with. Let's say I've chosen the XYZ plane. Now you see these features have now changed. All right, this is not the same feature as the solid one. This is now the another tab that came up, that is sketch. Now let's say I want to create um, a mesh kind of a structure. So let me take inspiration from my slide. Let's try to design this kind of a lattice structure, 2D lattice structure, which has some height. So it's a 3D lattice structure, and this kind of designs are very common for tissue engineering applications, because you see there are some big size pores, and if you bioprint it using a bioink with cells present inside these filaments, and when you dip it in within a vat of cell culture medium, then the diffusion rate becomes much more faster. So for tissue engineering application, these kind of lattice structures are very common and widely used. Okay, so let's try to design this. So how will we start? So I said I switched on the sketch option, and I also know that I want to create, let's say, 10 mm by 10 mm square. Okay, but if you see how this design is made, the first layer is like filaments are depositing in a Z fashion, and the second layer, the filament is deposited in a another Z fashion. So it is like stacked over one another. So in order to design this, we will not start with the rectangle, but rather, yeah, let's start with the rectangle. It will help you. So let me show you that. So I want the filament thickness to be, say, 0.6 mm, and the length to be 0.10 mm. Okay, this is my one filament. Done. Then another filament should join it, right? So let's say I've zoomed in. I've used my mouse to zoom in. This is the first point, and I want it to be 4 mm. It is 0 degree. This light basically helps me to adjust the height and all. 90 degree, you can see, you can always make sure the edges and all very nicely, like this. This is one L shape that is formed. Now this is the one, this is the one. You can now copy it. So it is asking you to select the features that you want to copy first. Okay, and create a copies. Make sure to click on that. Move it like this. You can change the distance, and then you can rotate it by 180 degree. You can then move it. Then I want to rotate it bit more, not like this, like this. That's it. You have to make sure the dimensions are correct always. You have to be very precise in your movements. If you have a mouse with you, it helps. So you can move like this as well. So yeah, that's it. Okay, so this is another panel that we have created. In this way you can do it again, you can repeat it again. Again you can select it, or rather, wait, let me select this one. Okay, I've selected the features, create a copy, and then move it. Yeah, that's it. Great. Okay, you can always check the dimensions as you're doing it. So you can see the dimensions are coming up right here. It is the filament thickness is 0.6 mm. It is 4 mm of distance is there, and this is around 10 mm distance. So if you don't see any dimension written, you can click on this sketch dimension. It will automatically get written here. So you know that the dimensions that you've chosen initially in your sketch is is exactly same in your 3D model. And this is, and I want another rectangle to be drawn here, and then I will continue with the next step. So it will be 10 mm, another is 0.6 mm. You make sure to click tab and then click mention the dimensions. So once that is done, you have to select the entire thing. This is a sketch, this is a 2D sketch, this is not 3D yet. You have to select the entire thing and press pull or extrude. These two options will do the same thing, right? And you have to then mention like what is the height that you want. Let's say I want the height of 0.4 mm. So there you go, a new body gets created. Okay, okay, this is your first body, right? So I got a body which is of 0.6 mm filament thickness is there, and the length of the filament is around 10 mm, and yeah, that's it. Now you want to create another layer but bit skewed, so I'm moving it around in order to show you how it is looking from all the 3 dimensions. If you want to come back, you have to select the home option. This is how it looks like. Now if you want to create a second layer, you don't have to start with the sketch option again. All right, you can use this move and copy feature. Now you have to select bodies. This is your body now. You don't have to select face. This is your body. And let's say create a copy. And where this copy will come, let's say this copy will come directly above it. All right, so directly above it. So I will then select 0.4 mm because this height is 0.4 mm, and I don't want any space to come in between these two layers. That's why I selected a height of 0.4 mm. Then I will rotate it. So I will use this axis to rotate it 90 degree, rotate it 90 degree. Yeah, that's it. All right. So yeah. So now this looks not exactly like this one, right? It's like something is missing, something is wrong. It's because I have not, thought well about what dimension should I choose in here. So another way, so how we can rectify it, how we can rectify this mistake now. You see this panel here, this is the timeline panel. You can always go back like this and you will get the structure as it is, and you can come back like this. So in this way you can rectify your mistakes, you can change your dimensions, all right, and like repeat, you can go back to your sketch feature and then come back. So in this way you will have to spend some time to understand um, which dimensions to choose. Okay, and this basic features that I demonstrated right now, those are very easy to help you get started. So if you have any queries so far, I hope you guys are doing it, means in your
Ma'am,
software. Yeah, go
you
ahead.
executed these things in a speed, right? Uh, it will take some time to do it in your speed, ma'am. Does it take, or it is easy to
No,
come up
no,
with these things?
you can just, you have to practice a bit, then you can do it. Even when I started learning it, it took me some time to understand the features and all, but just practice. This software is all about practicing, and as you think and practice more and more designs, try to make more and more designs, you can master this software. This software has a lot of tutorials available online as well, YouTube tutorials. Always look up what problem that you're facing and solution will come up. So it has a very big community, so you will always find. So you don't have to get flustered, like ma'am is doing at such a high speed, whether I'll be able to do it or not. It's not like that. You will also able to do it, just you have to get to hands on. If you're observing me doing it, that's why you're feeling a bit overwhelmed. Start doing it yourself. You will see that I have learned it in no time. Okay, and you have any queries in, like, you couldn't make the design that you wanted, you want me to help you troubleshoot why it didn't happen like that, the way I designed, you can come back to me and I can help you with that. Okay, so that's the part of the learning process. Don't get worried, you will learn too. Just if you have installed the software already, try to make something. Okay, I'll give you assignment after this class. Try to design the sketch that I'll give you in the assignment and into a 3D model. And if you guys face any problems in doing it, let me know. Okay,
Okay, ma'am. Okay.
the software is all about practice, so don't worry about it. But it's very fun software. You can create anything, like any CAD model you want, any 3D object you want. Not only for 3D printing, but you can also create 3D type of art if you want for your publication and all. So you can create those arts as well. Also, let me show you one more feature. This is a what? So this is a face, all right. Okay, these are the face that is getting selected. Now, if you want to combine these two bodies, how will you do it? So this is a feature called combine here. All right, we have to select the target body with which you want to combine and the tool body which is going to be combined. You select both of these, then some operations will pop up. You can join, you can cut it, okay, or you can intersect it. So the intersected body will come up. So I don't want to do cut or intersect, I want to join it. So once you join it, okay, so now you see the body is one. This is the one entire body. You can go back and see that initially it was body number 1 and this is body number 2. Initially it was 2, but when I did the combine option, you get 2 of them. Then you can also do sketch on one of these faces of the body as well. So you can select the face, right, and you can zoom out, zoom out, and there you go. This is the face. You can use this panel as well to move. This is a selected face. So you see this is colored slightly different from the other. You can only sketch on this face, not on other faces. Okay, you can try it. You can try sketching on another face, but you will see that you will face some error. So you select this face. Let's say I want to create a cylinder coming out of this face. So I'll start with a circle like this. Let's say I want a cylinder of radius 0.5. It's too big. 0.2. Okay, you can also create like modifications in this circle. Since I don't need it, so let's not worry about it. And once you're finished, you can select escape button and you will come out of the option. This is your sketch now, and from this you want to create a cylinder. So you can press pull or you can extrude, and like this a cylinder will come out. You can select an join option or cut option. Then what will happen, it will cut a cylinder like this. Or if you select join option, you will see a cylinder is getting joined to that face, right? You can change the distance, you can taper it as well. So just play around. So like this you can taper it. Like you can create not a cylinder but rather a cone kind of a structure. So I'm just playing around. I don't have any design currently in my mind. I'm just trying to show the features, but yeah, you can do it. And let's say I don't want a cylinder, I want a tapered stuff. So still taper it a bit more. In this way, yeah, you can create some stuff like this. Yeah, and then let's say okay, I'm happy with it, so this is something that I want. There is another interesting feature that I like when you want to create multiple objects. All right, means pattern type of, when you want to create a pattern, so you can create and go to pattern. Let's say you want a circular pattern, and this is the body that I want, that repeated multiple times. This is the object, selected this object, so selection is done. Then you have to select an axis. Okay, so it will come out. So I want the axis, let's say, in this direction, and what you see, a circular pattern is coming up in this rotational kind of a thing. 6, or maybe I can deselect. If I'm not happy with this axis, I can deselect it, and let's say I want to choose this axis. Again, I'm not happy with it, so let's say I select this axis. All right, that now it makes sense. So I can create 10 out of this or 20 out of this. Okay, and circular, so um, we can create a semicircular pattern as well, symmetric pattern as well. Okay, I want it full, so I want 20 of this in a full circle. Okay, so in this way you created one body you created, and you created a pattern out of it, and yeah, multiple of it you have it. Suppose you don't want a circular pattern, then here only the feature comes up to make a rectangular pattern. Again, the body has to be selected, so this is the same body. Then you have to select the axis. Let's say this is the axis I want to do, and then since it's rectangular, you have to choose the length and breadth. So yeah, so here, since I've based on this axis, it is coming like this. I'm not happy with it. Okay, so let's go back. Let's go back and select different axis now. Now I'm happy. Yeah, I want all the bodies to be lying on the XY plane. This is the axis. This axis sounds good, looks good. You can again change the number here, how many number of bodies you want. You want, let's say, 10 of these. So yeah, 10 will be lying here, and yeah, nice. Here you can choose this option as well to change the numbers. So it's like we have to play around. There's nothing more to do here. Okay, you can also extend it, choose the spacing, right? If you choose a spacing of 10 mm, it will be like this. If you choose a spacing of 20 mm, it will be like this. So in this way, you can create multiple of it in a pattern format. Okay. Then this is another interesting feature called resolve. So here, suppose you design something. Let's try to use this as a resolve feature. Let's again go back to the sketch feature, and let's create a circle. Select at a center, say 30, and uh, let's create an offset. Means I want like this. When you select an offset, you can create the same thing again, like repeat it. Right? Makes sense? Okay, let's do this. I'm happy with the sketch, and let's exclude this part only. Let's see what happens. Extrude it to height 10 mm. Okay. For resolve, we have to select a profile, okay, and an axis. So when you do it, so what is happening? this circle, so sorry, I created okay too soon. I have to select an axis. Move it, select an axis. Now you can create a new body. You see what we got? We got a donut like this. This entire thing got revolved all around and it gave you a nice looking donut. Looks cool, right? Now you can change the angle here. You want, let's say, only 180-degree resolve. Then it can give you a pipe like this. Okay, or you can change the angle yourself. Half pipe. That is a very interesting feature of resolves. So yeah, I got a pipe like this. Let's say I only want up to 90-degree. So you got a hollow pipe like this. That's the powerful thing. That's a very powerful thing to use. That is resolve. Then you can also this pattern feature, you already saw it. Here is it is in pattern. Then let's say you want to split a body. Okay, so we joined these two bodies here, right? This is now a one body, I guess. Did I? This is one. How when you select it, you can see the body gets selected as body number 1. Where is the third body? This is the third body here. These two are not joined. You see, a new body gets formed. So what you can do, you can select this body and combine, select on combine. The target body is selected. Then select the tool body and combine. Okay, now suppose you didn't want to combine, you want to split it. So you have to select the split body. What is the body that you want to split? There you go. And what is the tool that you want to select? So tool is basically surface through which the splitting will happen. Let's say this is it. Am I happy with it? Let's see what happens. Okay, now this part has become a different body. Let me show you. You just have to move it. Oh, sorry, move body, not move faces. You will see like this, the body is separated. Yeah, this way you can split it. So depending on what your final objective is, you can create very amazing structures using these tools. All right, and yeah, if you have any more queries, I'll give you assignment. I'll give you one assignment to create a very simple lattice structure to help you get started. But on meanwhile, you can also try on your own to create more and more structures. Let's say you want to create a pen holder, or you want to create a bottle like a bottle like this. You can create it here in this CAD model. Then you any realistic object that you see around yourself and you want to practice, you can take that object as an inspiration. Choose dimensions, like make sure you understand the dimension of the object very nicely. Means if even if you see the object in front of you, like say this bottle, you should decide beforehand like what is should be the diameter of this bottom. Okay, then the curvature of this, like you should like get that thing going on in your mind by drawing it. You have to draw it first in your pen and paper, so that when you start actually doing this CAD modeling, as you can see, this software is so big, you can do so many things. But if once you're sure what you want to do, then these features become automatically useful to you. Okay, you won't fumble like how do I do this, how do I do that. You will know, okay, the main utility of that feature once you start designing anything on your own. Okay, make sense?
Yes, ma'am.
Yeah. So how many of you have been trying the software on your own, like I was explaining? or were you just listening? Like, I just want to know if any one of you has tried while I was speaking this around 1 hour or more than that. Have you tried exporting the software yourself in your computers?
I'm just listening you, ma'am. I tried to
Oh,
download it, but it
okay,
is
okay.
didn't
Yeah, yes,
work.
yes. You should download it first. If you haven't, you should
Same here.
download it first. Okay, okay, it's fine. I'll give you an assignment today. It will pop up in the Google Classroom forum. Try to design it, and whatever queries you face during the assignment, post it in the Google Classroom, so that others will also um, will have a look at it. And if they are facing the same problem, they will just read the post, right? So take help of the Google Classroom as much as possible, so that you all the common collective queries during the course get answered in a quick manner. You individually don't have to email me every time for it. Okay, so I was just thinking what else I can show you today in the software. So yeah, one important thing. Now suppose you're happy with the CAD model you designed. So I'm not happy with this one either. I'm happy with this one. Just go back in the timeline and you will see. I want these two bodies to be joined because I'm thinking to 3D print it. Okay, so this is the target body. Select the tool body and join. So there you go. This is body 1 and this is body 2. This is completely one body, sorry. Now you want to 3D print it, so you have to export it. Now you can export it in multiple ways. You can right click on the body that you want to export and save as mesh. You can do this way, and it will pop up option like this. You have to select the format. So there are multiple formats available. Remember, for 3D printing you want STL binary. Okay, so and the unit type that you see here should be millimeters, but if you prefer inch, meter, foot, that can be also done same, but you have to keep the unit consistent in your mind. If you have designed your um, sketch in millimeters, then choose millimeters. Okay, and then you can preview it how the tessellated structure looks like. So there you see the structure is having series of triangles, right? And this is what the CAD model, the 3D printer will be able to. So this is when you supply this to a slicer file, it will read this. So let me show you some slicer software as well. Okay, that will be nice. You don't have to install the slicer software, but for demonstration let me show you. So let's say this is the body I want to 3D print. I saved it as mesh. Let's export it, and I want to save it in my desktop. Done. Now I want to 3D print it. So the STL is ready, but I have to slice it first. So recently I have been working with the slicer called Prusa Slicer. This is a slicer software for the Prusa 3D printer. Alright. Uh, so this is the software, how it looks like. You don't have to install this software, just I want to show you how the slicing happens. So let me just open import. Sorry, I have to first import an STL file. So this is the body that I just exported. So there you go. This is the STL file that I want to slice. Now this software allows you to select the printing speed. Now usually I have, like, if you want to make very fine details of the structure, you can go up to a speed, very low speed of zero point 0.1, or you can select a speed of say 0.2. This is standard one. Alright, or you can choose like any speed that you like. Let's say let's choose the standard one. You can have to choose the material, what material you're going to 3D print here. So I'm using PLA, and that is to made by a company called Overture. So that material is there, and then you have to choose the nozzle, right? Then so the original machine, this machine that I'm using right now, Prusa original Prusa MK4. So this machine comes with the nozzle of 0.4 mm, so that is why it is selected. Now if you want support right? So suppose your structure needs it's a hanging, right? So if you see my structure is bit, sorry, you can zoom in, zoom out, and you can use the mouse to move around. So you see there is a bit of hanging here at this spot. So maybe I'll add some support. So support on build plate only. Did it form? No, it didn't. So it's a very smart software, right? It will detect the structure, whether the structure needs a support or not, and it will do it for you. So since it said that support is not needed, so it didn't build any. Now I told you about infill density. So what is infill density? It tells you how much of the material will be excluded out. So, and also dictates the final strength of your structure. So if I increase the infill density to say 20%, then the material spent will be more. Means you will have much more thicker material. You will use up most of the filament to make the structure. So usually it is recommended to go up to 20%, but you can also go up to 100% as well, but this is not supported. So yeah, better to choose below than 20% so that you save on your material. So let's say I choose 10%. Once I do that, there is the option just below it, slice now. So it generated a G code. The software generated this G code. You see, it has made a parameter that is saying that it will take around 10 minutes. All right, the infill, it will 18% of the material will be used. How much material will be used, it is also showing. All right, and this is how the sliced structure is looking like. This is how your final structure will look like. And once you're happy with the slicing thing, you can export it. So it has also written that it will take around 41 minutes to complete this entire print. Once you do that, so this is the pattern. So you see this, the lines that you see here, if I zoom in, this is one line of material that will get extruded. So this is the path. The print head will move and extrude the filament to create this final structure. So the software is doing everything. School, right? You don't have to worry much about this slicing step because softwares exist. You only have to focus much more on the design, what you actually want to make, the dimensions and all. Once you're happy with it, you can export the file. Okay, it will get exported in a G code format. Then press OK. So it is exported. So this is the G code format. So usually it doesn't open up in a normal file. You may have to use softwares like Notepad and all to open the G code. So let me show you that. No, can I show you? So actually I cannot. I don't have that software in this computer with me. But let's try if I can open with a Notepad file. Sorry, text editor. Oh yeah. So with text editor, I could open it, but it's writing abrupt stuff. So yeah, that is not a good software to use. You can actually open it here. I guess. Mm, open with Prusa. All right, and yes, it's opening. This is the sliced file. You can see the travel path of the printer. So how the printer will move. See, it's very complicated if you look at it. It's very complicated. This is how the printer head will move. Then custom G code. So you can choose the temperature here, what temperatures to choose, volume, where the volume will be used more. So it's a like again a cool software to explore, but this software will only help you to create G codes when you are going to 3D print with this machine, original Prusa MK4. So this Prusa 3D printer will, when you're working with a Prusa 3D printer, you will have to use a Prusa software, Prusa slicer. Similarly, other companies will have their own slicing software, but if you are suppose custom making it, then you can use slicing softwares like Slicer or Cura to slice your 3D printers, 3D slice your STL files, and finally 3D printed. And as I showed you in my slide, a G code will look something like this. Okay, where it's like say a set of instructions, and you can edit it in a notepad. This is a software called Notepad plus plus. So that is not available in Mac, that's why I don't have it with me. It is only available in Windows. So in Windows software, you can install it, and then you can open this G code file that you just exported, and then you can edit it. Okay, so I usually have a Mac, Windows computer with me as well. I keep both. You know, sometimes one thing works well in Mac, other things doesn't. So yeah, Mac has its own disadvantages as well. What to do? So this is the software Notepad plus plus. You can download it, and is it available on Mac? Yeah, I don't think so. Yeah, and this software allows you to open file of any format basically. Okay, you can even open C++, Java, Python files in this. So it's a free software and doesn't have any bugs or anything. So yeah, you can have this software for other purposes as well, not just for editing G code. So yeah, what else I can show you? This is one way. So this is this machine. So this software that I showed you, Prusa one, is for one printer, Prusa 3D printer. That is an extrusion based printer. Now you can, if you suppose you're working with stereolithography based printers, you know what a stereolithography, where the fourth type of printer that I showed you, where light is playing an important role. This will have its own software, and there I'll show you how the slicing takes place. Let me open that software quickly for you. The software is called Chitu Box. Why can't I say it here? Yeah. Where did it go? Hmm. Did I delete it by accident? I think I did. So yeah, I don't have the software currently with me. Deleted it by accident, sorry. So there's another software called Chitu Box that helps you 3D print. So let me quickly download it. It's a very small software. You can use this software to slice STL files for 3D printing, you know, for 3D printing, stereolithography based 3D printers. In like there is Elegoo, and then these companies makes these kind of 3D printers, and you can create very sophisticated structures like this. All right. So I have done it here in US, and yeah, it's it's the 3D printing world is like having much more convenience for new users. The software is readily available. Only thing that one needs to learn is CAD modeling first, right? So that that person can actually go ahead with the 3D printing. So you have mastered the CAD modeling, all right? Try to master it at least to the beginner level, so that if suppose in future you are given some project and you were asked to do 3D printing, so you know where to start, right, or how to start. That's the objective of this course. I don't want to overwhelm you so much, just want to keep it very simple. And yeah, the assignments that will give you will definitely help you practice. Okay, so I think we are almost done for today's session. I just want to ask if any more queries that you have, and we will spend some time on it, and then yeah, I'm done from my side. Yeah. If anyone has any queries, let me know. Did you find today? Yeah, go ahead.
Ma'am, is there a chance you can start the class from 6:30, ma'am?
6:30. Yeah, it's fine. Yeah, you
Yeah,
can do
okay.
it on from 6:30 to oh, 10, I guess. Yeah, 6 to 8, right? So 6:30 to 8:30. Yeah, 6:30 to 8:30.
Okay, ma'am. Thank you, ma'am.
Okay, I'll post it in the Google Classroom so that others will also come to know. We can start at 6:30. That's fine. I hope we are not going to disrupt the dinner time. Means that's why I kept it till 8. Because maybe because people will have dinner after 8, so that's why. Others are comfortable, right, with 6:30? Is it okay with others?
Yes.
Yeah. Okay. 6:30. So we will meet next week from 6:30 onwards, and the class will go on till 8:30. So around 2 hours of class is fine. Yeah. Okay. This request is accepted. Anything else? Did you find today's class interesting? Did you learn anything new?
Yes, ma'am.
That's good. Um, yeah, I'll stop the recording so that you feel free to speak up.